All right, so I've got a kind of short, small example to kind of just prove to you and show you like what I'm saying is true about these sampling distributions. I showed you the numbers, but yeah, I want to show you a little more practice what this would look like. So you're not going to have to do this. You're never going to have to reproduce this. I just think it's helpful in understanding a little bit more about what's going on. So here I've got a bunch of different students. 431. So it's a lot of the students that I had in a previous stats course that I taught, actually. And the average grade in that class was right under an 80. So the true population mean, all I did was find the average, right? Use that built-in average function. In fact, let me zoom in a little bit more here. I think I usually put it at 200, so it's easier to see. I then counted the total population size, 431. Here I took the population variance of that letter grade, and then I said, okay, look, I'm not going to expect you to know to do this part, but I generated some of these random numbers and they set seed numbers so that I can kind of do these random lookups, right? So I'm choosing random numbers, right? As I choose these random numbers, I'm then going to kind of look them up. Whatever ID number it is, I'm going to find it and then put that person's grade. So notice here, 15, right? We looked up, oh no, that's not what it is. Sorry. This would just be my random number, sorry. And then generates a random number, matches it up to the student ID, and puts their letter grade in, right? Um, so I'm not going to expect you to know how to do that, but that's what this is doing. Creates a random number, looks it up in this column. Once it finds it, it then looks at what the letter grade is, puts the corresponding letter grade into this cell. Now notice every time I like click in and enter, it's generating new samples, right? So I did this for one sample, two sample, three samples. I believe if I go all the way over, the number of samples I took, I did count how many samples I took. So starting with the first sample going all the way to the last, I had 1,000 samples. Okay. For each one of these samples, I took the samples were of size 50. And this is actually for something else, so we can ignore this for right now. For each sample, I calculated the sample mean. Right? So I've got all these different sample means. Right? What I'm then going to do is say, okay, look, I've got this collection of sample means. What is the mean of those sample means? Well, I can use the average function, go up to here, command shift or control shift or command shift on the Mac, hit the over arrow, hit enter to get out of the cell. Notice the mean of my sample means ends up being almost identical to what that true population mean is, right? 79.8, 79.8. It's off at like the second decimal, but it's because I only have 1,000 samples, not like an infinite number of samples. Okay. If instead I wanted to find the standard deviation, actually, did I do the variance? I think I did the variance before. So the variance of our sample means it should simply be the original variance, right, divided by the square root of our sample size. So what it should be is our original variance, and then go down so I can show you, divided by our sample size. So it should be 4.28. If I use that variance equation, and here it's a little bit tricky because I'm just trying to treat like a population, because this is like the population of sample means that I have. I'm going to select all of my sample means to find the variance. Now it's a little bit off. In fact, I probably have done, no, actually, sample should inflate a little bit. So it's close. I mean, if I notice I start playing around with different random samples, I'm getting pretty close to that variance, right? Now, what's one reason why I might not be getting exactly that correct variance? Well, if I took samples of size 50 and I had 431, so this would be kind of like, do we need the correction factor? Well, we said if we have more than 1/20th of the population, so if I take my sample size divided by this, sure enough, I've got a little bit more than 1/20th, right? I've actually got more than a tenth. So I really should be applying that correction factor when I'm thinking about what the true populate, or sorry, what this true variance should be. So here, it won't simply be um, this. I need to multiply it by my correction factor, which is taking the population size minus my sample size, dividing that by population size minus 1. Hit enter. What did I forget to close? Oh, I wanted to divide, not question mark. Notice there, okay, my standard deviation should be a little bit lower. I'm still not quite finding exactly, and that's because I only have 1,000 different sample means. Um, but if I generate more and more random samples, I'll see that this kind of bounces around. Um, so just kind of showing there, if we do get a sample that's too large, things kind of break down a little bit. Okay. Um, what else do I want to show you here? Let's say if I select all of this data, and let's go to insert. I don't think this is going to work actually. There it goes. So I selected I couldn't remember if it needed it to be vertical. But if I select all those sample means, I then kind of look at what that distribution of my sample means look like. Pretty close to a normal distribution. It's not perfect, but pretty close. Okay. So the mean of my sample means should end up being the exact same as my population mean. We saw that hold. Oh, now I got to drag this thing all the way over. Well, we saw that the distribution should be kind of normal. Actually, let me cut this and then go back over to the data so I can kind of save this so you have it all in the same place. All right, so the mean of my sample means really close to that true population mean. Standard variance follows pretty closely to that equation. In fact, I don't apply that correction factor here. I'm getting something somewhere. And then pretty close to normal distribution, right? Now, like I said, we can't completely prove this to ourselves because I've only got 1,000 samples here. I truly, in theory, need an infinite number of samples to prove this, but I think this is pretty good support, right? Now, the other thing I wanted to show you that hopefully piques interest of some people because it is interesting. And I hope that if it does look kind of interesting to you, you might want to take the next class of 371, which I think we get to do a lot more fun things there. So let me pull this open. So there's a program called Stata. And actually, let's see, I'm on a different computer. Is this going to be the right? Yeah, cool. Um, and it's like Excel on steroids. So it's a lot more coding, but it's another data management program. So I'm going to come down here and do this. Oh, didn't like so. Oh, because I'm on my cloud storage. So OneDrive. Oh, here I know. I moved the file. So we'll get this working here. So I'm gonna take this, open. Here's my global. Apologize. I thought I had this set up, but I forgot that I have to change the file path. Maybe. Um, there we go. Now let's see if this works. There we go. So I have this NBA player data, and it was height data. So I'm just going to use a height variable. So I'm going to just keep the height variable in the player's name, right? So if I looked at the mean, 79.1. If I look at the standard deviation, 3.54, variance, 12.59. Okay. Don't worry about this command. I'm going to create a program that basically is going to run for 1,000 different reps. It's going to randomly kind of grab, oh, and what did I have it set to be? A sample of size 10. So I'm just sampling size 10 here. And then it's going to spit back out at me what my sample mean is. Okay. So I'm going to do that. I'm then going to summarize this variable means, which is all these different sample means, right? So if what I was saying before holds, and actually here, um, I don't know if there's a way for me to, oh, well, I thought I could zoom in on this apparently. I can't remember what the exact thing is because I usually am doing this for myself. So let's see. Um, Zoom. There we go. I knew it was somewhere. Um, well, it's about as much as it goes, huh? All right. Well, we'll have to put up with this. So we can kind of see the mean before is 79.14. If I now summarize my sample means, the mean of my sample means 79.14, exactly the same as before. My variance should be the original, or sorry, yeah, the variance should be my original variance divided by my sample size. So my original variance was 12.5, sample size was 10, so it should be 1.25. Okay, it's not real far off. Once again, I only have 1,000 observations, so that's why it's a little bit further off, right? But the same kind of thing holds, right? Now I could do the same thing for samples of size 30. What should be the case is I get the exact same sample mean, once again, really close to that 79.14. And the variance, right, I'm dividing by a larger sample size, should be getting smaller and smaller. And then I could do the same thing for 100, right? And here I think I actually changed the reps to 10,000, right? So now it should be even more precise. This actually might take it a second to run. In fact, it is. There it goes. Sure enough, 79.135, very close here. The variance, taking sample size 100 instead of like 12 point whatever, it should be 1.2. I'm getting really, really close here. Um, so yeah, just kind of actually, let's see here. I think I can do a histogram of the sample means as well. Once again, 10,000 might take a second. Wow, really close to a normal distribution here, right? So I can kind of prove this to myself with data, especially if I can do these 10,000 different samples. If I had more time in the day, I could run it 100,000 times and it'd be even closer, okay? So just another way of looking at this. It's not in Excel. I'm not gonna expect you guys to use this, but I do think it's interesting to kind of see what that next level is. I'll probably reintroduce a little bit of this to you when we look at regression to kind of see what we can do. But we did a very similar thing, just not quite as easily. It took a lot more space, a lot more work to do it right here as well in Excel. Okay. So this is sampling distribution, Excel kind of work. The next chapter, we will look at how we build confidence intervals for our population mean.